Today's problem will be question 2 from 2015's AP Calculus BC free response question problem set. The problem is, at time t is greater than or equal to 0, a particle moving along a curve in the xy plane has position x of t, y of t, with velocity vector v of t is equal to cosine of t squared, comma, e to the 0.5 t. We also know that at time t equals 1, the particle is at the point 3, 5. Part A. Find the x-coordinate of the position of the particle at time t equals 2. We know that the x-coordinate of the particle at time t equals 2 is x of 2, but we only have x of 1. So, using the fundamental theorem of calculus, we can find x of 2 by having our initial condition be x of 1 and taking the integral from the initial condition to the desired condition. So we take the integral from 1 to 2 of the x part of the velocity, which is the derivative of position dt. Plugging in what we know x of 1 is equal to 3, and the x part of the velocity is cosine of t squared. So we get the integral is 3 plus the integral from 1 to 2 of cosine of t squared dt. We can plug this into a graphing calculator and get 2.5569. So either rounding or truncating, we get the answer that the x-coordinate of the particle at time t equals 2 is equal to 2.557 or 2.556. Now let's look at the scoring. This problem is worth 3 points. We have 1 point for having the correct integral set up, which is the integral from 1 to 2 of cosine of t squared dt, and then we get another point for using the proper initial condition of x of 1 equals 3, and then we get a third point for having the correct answer of 2.557 or 2.556. Part B. For time t is greater than 0 and less than 1, there is a point on the curve at which the line tangent to the curve has a slope of 2. At what time is the object at that point? We know that to find the tangent line, we need to find the slope, which is dy dx. Although we aren't given a function for dy dx, we can solve it by taking dy dt and dx dt, which we know are the points of the velocity function. Dy dt is the y part of velocity, or e to the 0.5 t. And we also know that dx dt is the x part of the velocity function, or cosine of t squared. To find dy dx, we just divide dy dt by dy dx to get e to the 0.5 t all over cosine of t squared. And we also know that this is equal to 2. We want to find at what time t the object is at that point. The best way to solve this is by plugging in a graphing calculator the graph of this function. By replacing t with x, we can graph two functions on a graph. Y equals e to the 0.5x all over cosine of x squared, and y equals 2. Where these two graphs intersect will be where e to the 0.5t over cosine of t squared is equal to 2. After graphing these two functions and finding the intersection, we find that this happens at t is roughly equal to 0.840. Again, let's look at the scoring for this problem. This problem is worth 2 points. We get 1 point for having the slope in terms of t, that is dy dx is equal to e to the 0.5t all over cosine of t squared. And we get another point for having the correct answer, t is equal to 0.840. Part C. Find the time at which the speed of the particle is 3. First, we have to note something very important, that speed is the length of the velocity vector. Using Pythagorean theorem, we can find that if velocity is x of t, y of t, then speed would be the square root of x of t squared plus y of t squared. Plugging in our known formulas for x of t and y of t, we get speed is equal to the square root of cosine squared t squared plus e to the t, and we're also given that this is equal to 3. We can use a similar method to the last problem where we would replace t with x and graph both sides of the equation on a graphing calculator. So we would graph y equals square root of cosine squared x squared plus e to the x, and we would also graph y equals 3. Where these points intersect would be where the speed would be equal to 3 at that x value would be equal to the t value at which we want. So plugging these into a graphing calculator and finding the intersection point gives us t is roughly equal to 2.196 or 2.195 depending on whether we round or truncate the value. Again, let's look at the scoring algorithm. This problem is also worth 2 points, and it's similar to the last problem. We get 1 point for having the correct speed in terms of t, that is square root of cosine squared t squared plus e to the t, and we get another point for having the correct answer of t is equal to 2.196 or t is equal to 2.195. Part D. Find the total distance traveled by the particle from time t equals 0 to time t equals 1. To find total distance traveled, we need to take the integral of speed between the designated time intervals. So we know speed from the last problem is square root of cosine squared t squared plus e to the t. So we integrate the speed from time 0 to time t dt, and by plugging this into a graphing calculator, we get an answer of 1.59461. So either rounding or truncating this value gives us the total distance traveled is 1.595 or 1.594. Finally, let's check the scoring once again. This problem is worth 2 points. 1 point for having the correct integral setup, which is the integral from 0 to 1 of square root cosine squared t squared plus e to the t dt, and another point for having the correct answer that the total distance is equal to 1.595 or total distance is equal to 1.594. This was problem 2 of 2015's AP Calculus BC free response question set, and I hope this was helpful.